Hi everyone, this is Francisco. So, I'm technically recording this video because I wanted to show you guys, and I think the fan's messing up my video. Okay, so now that I'm all situated, I wanted to talk about our galaxy, but mainly maybe not our galaxy, maybe just our, like it says here, solar system with planets, planet, galaxy, stars, digital set of 5 files. Actually, it looks really nice. Let me see here, galaxy, solar system. So, one thing I wanted to point out is a number of things, and I'll get to that very shortly, because this might take a while. Just be prepared. At least 30 minutes, maybe an hour. Hopefully I can cover what I'm about to say in less than that time. However, I wouldn't count on it. So we can tell immediately that these images are fake, just because of the lighting and stuff like that. I don't know if this is a real one, but this one looks more realistic. This one right here. Because we can see the light, the sun's light, and how it's shining on this object and this object over here. And then behind it, there's a black shadow. Over here as well, there's a black shadow. You know, because everything has a shadow to it. It's just like my hand. Right underneath it, you guys are going to see a shadow. Why? Why is that? Because right above it, there's a light. That's why. Excuse me. So these planets that we are in, well, we're just in one planet. You know, humanity is in planet Earth as we know it. But it could be a possibility that humanity is in each and every single one of them already. People that have adapted to these planets, just like us on planet Earth. But like, I'm thinking maybe these people adapted to their environments, but that's not my point here. That's just a theory. Just a theory, okay? But my point is that we are all in a bunch of circles, right? Bunch of circles. There's a bunch of circled objects in space, including the sun. And I wanted to point out, because I'm going to get involved with, I'm going to discuss, hopefully I can get around to it, but I want to discuss how fast the Earth is traveling around the sun, or how fast the Earth is spinning. Actually, we know the rotation of planet Earth, and it rotates at an axis, and it takes 24 hours for a complete revolution. Okay? For a complete revolution, for it to go in a circle completely one time. It's like if you guys were to roll a ball, a big heavy ball, and it required like 5 or 6 people to roll it, and someone said that it would take 24 inches for it to do a complete rotation. The inches would represent the hours, right? So that's how Earth is. It takes 24 hours. So I also want to pull up a clock with 24 hours. So we're going to see like a diagram. I believe that's what it's called. So we can see here that we have a clock that has obviously the day hours. It has both day and night hours, but I want to show you guys how this connects to the moon. And I can see here moon phase clock. I really want to take a look at this because this is a very interesting moon clock thing. Now, what I'm about to share is super... Wait a minute. You guys see this right here? This is like... This is all related to what I want to discuss. I don't know, like historically, and I think maybe even scientifically, I don't understand everything that has to do with obviously the clock and how it relates to the stars and to the moon, because obviously the clock, I think, was invented for planet Earth. However, I wanted to share some information that I think a lot of you would be interested in. And I started this video off by sharing, by searching for the moon first. It says, hold on. It says the radius of the moon, orbital period 27 days, Gravity, distance to Earth. Whoa, distance to Earth is 238,900 miles. What the heck? That's insane. Especially considering the fact that they were able to successfully send humans to the moon, I believe in 1970 something or something like that. If I know my math correctly or my history correctly. I actually want to look into that real quick. So just give me 1 minute. Which landed 12 men on the surface between 1969 and 1972, right there. So those are the years. So that wasn't that long ago, right? That was like 70, like 50 years ago. I'm actually surprised that they were actually able to successfully do that, especially considering how many miles it is from planet Earth. I mean, you guys can imagine yourselves traveling, you know, how many miles? Maybe 60 miles, maybe 6,000 miles. But this number, like, where do they get the fuel? How is this thing moving? Think about it. Where do these people get the food from to survive? How fast was this spacecraft traveling at? You know, all those are fascinating, interesting questions. But let me see here. So this one right here, this picture of the moon, is quite fascinating, and if you guys are old enough and mature enough, you guys know exactly where the sun is located based on this image right here. Like, I showed you guys my shadow. You know, for those of you that don't really know and understand, if I place my hand right underneath this light, the shadow is going to be casted right underneath it. If I place my hand over here, obviously the shadow will be over there, and it is. You guys can see it, right? You guys can see my shadow. right there, right? Why? Because the light is right there and it's coming this way, and then it casts the shadow. Because the light can't penetrate through my hand, right? So the light is basically reflected. It's basically, it already landed on an object, and it can't wrap around my hand or an object that I know of. But either way, I noticed. Let me just get to my point. When we as humans are on planet Earth, and let's say this image right here, let's say that it's spinning clockwise, and we on Earth are in the time frame of a sunrise. So when the sun is rising on planet Earth, that means that we, in perspective to the moon, we are right here, right here. Why? Because that's where the sunrise is at this point. Okay? And then we know the center of this light, the center of, because it's just a ball, it's just a circle. Okay, so if the light is over here, that means it's 12 o'clock right here. Alright, and going back to the clock, I would preferably like to use 6 in the morning. I'm having a difficult time still processing this information. However, I think I need more space for me to illustrate this a little bit better. But anyways, so we have I already specified that this is 12 p.m. At 12 p.m. is it's basically I think the hottest point, and when the sun is directly above planet Earth. Okay. That's when it's 12 o'clock. Because we're talking about a perfect circle here. Okay? So this is 12, which means that I'm thinking in perspective to 12, we have obviously 9 and 3, but we also have 13 through 24. Okay, so technically the 1 through 12 will actually be I think this is turned, and I think it's like this. You see, there's a light, and then over here we have dark. Right? I think this dark section represents the darkness, the night, while this side over here represents the day. So this is from 6, like basically 6 in the morning to all the way to what is this, 18, this is kind of complex. This is kind of difficult here. But we have wait a minute. We have 6 all the way to 18. So 18, it's the opposite. Wait, it's not the opposite of 6. So it creates a bigger circle, which we have here, because it's number 1 all the way to 24, which is right here. It says 0 and 0. So the 24 mark will actually be 12 a.m. The opposite of that is 12 p.m. Right? Because if we were to get 12 p.m., the opposite of the world wouldn't be 6 p.m. That would mean that it would be barely nighttime when it's 12 p.m. on the opposite side of the world, which will be impossible. And I think that it just wouldn't create it wouldn't equal to a perfect circle. This over here makes more logical sense. This is military time, 1 through 24, 2400 hours. Okay, so when we look at 12, this is the brightest point during the day when the sun's all the way up, right above you, right? And then, whoa. And then on the other spectrum, the other side of the world, I'm sorry, is 12 a.m., which is I believe probably the darkest point during the whole night, but I could be wrong. But anyways, so that would mean that this is 12 p.m. right here. The opposite side of this circle will be 12 a.m. So let me actually take this one and place it over here. Alright, so Jesus Christ, what the okay, like I said, we have 12 p.m., a.m., and then what would be the opposite, or in between these two, it would be 6 p.m. like right here. Well, actually, I said if it's rotating this way, so yeah, this will be 6 no 6 12 a.m. 12 p.m. 12 a.m. I think this is 6 p.m. No, because it's rotating this way. So this is 6 p.m. and this is 6 or 1800 hours, which also equals to, if we look at a clock, man, this thing, so 18 will be yeah, 16, I mean 18 p.m. nighttime hours. Nighttime hours because the light of the sun the light of the sun, I'm thinking the light of the sun will be rotating to the right side, like clockwise, not this thing rotating clockwise. So I hope you guys understand, like, let's assume this light travels this way, clockwise. So obviously over here will be it will be sunrise, and over here will be sunset. Okay, the opposites will be happening. So over here we have the sun rise. Down here we will have the sun set. Right here we have the hottest and the brightest time of the day, you know, when the sun's out, while the opposite side is the coldest and the darkest, right? Obviously, if we're talking about planet Earth, then, you know, this will differ based on the basis if the moon is, if it's not around, if it's like over here, like where it's not visible to us, you know, because if the moon is on the dark side of the moon and we can see the moon in the dark side, that means that some of that light, from what I heard, will bounce, reflect off of it, and it will get reflected to, you know, to planet Earth. So it's basically considered the lights of the moon, and I think there's a scripture like that. The light of the moon for the night. So it says God made the greater lights for the day and the lesser lights for the night. Scripture. Right here, it's Isaiah chapter 30 verse 23, New International Version. The moon will shine like the sun, and the sunlight will be 7 times brighter, like the light of 7 full days, when the Lord binds up the bruises of his people and heals the wounds he inflicted. What? I have no idea what that's describing. It's like, it almost seems like that's the first time I ever read that. Genesis chapter 1 verse 15. Let them sun and moon be for lights in the expanse of the heavens to emit light on the earth. Genesis chapter 1 verses 14 through 18. And God said, let there be lights, plural, in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years, and let them be lights in the expanse of the heavens to give light upon the earth. And it was so. And God made the two great lights, the greater light to rule the day, and the lesser light to rule the night, and the stars. And God set them in the expanse of the heavens to give light on the earth, and to rule over the day and over the night, and to separate the light from the darkness. And God saw that it was good. Okay. So that's what I was referring to. So, going back to this, obviously, if you don't see the sun directly above you, that probably means because you're at a different point. I think it's considered the equator of the equator. But let's look at that. Let's look that up. Equator. It says the equator is a circle of latitude that divides a spheroid. I don't know how to pronounce that word. Such as Earth. In the northern and southern hemispheres on Earth, it is an imaginary line located at 0 degrees latitude, about 40,075 kilometers or something, km. I'm not sure what that means, which is equivalent to 24,901 miles in circumference, halfway between the north and south poles. The term can also be used for any other celestial body that is roughly spherical, whatever. So if you don't witness the sun right above you, because I think like even in Alaska, the sun at noonday will be pointed, well, it will be like in the horizon. It won't be directly above, because you guys are at a different location in the equator, you know, in the world. So if that is the case, then that will also allow you guys to know where you guys are in this circle right here. Okay, you might see the sun, or you guys might see, yeah, you guys might see the sun during the day, and you're looking at it at 12 p.m. I think that's when it's the brightest and more like vibrant. It's either that or I'm wrong, and the clock is actually shifted either clockwise or counterclockwise. But either way, whether it's 12 or 3 or 6 on the clock, in perspective to the clock, what's it called, it will be simple math for all of you to understand what I'm talking about, because you know the clocks act like a compass as well, right? If you're smart enough, you can figure it out. And obviously, like right here it says that it's 8 in the morning. Well, according to the time, it's 8 in the morning, right? See, but yeah, it is 8 in the morning right here. Yeah, because I think this would be considered 12 a.m. 1, 2, 3, 4, 5, 6 in the morning, 7, 8. Obviously, 12 at night, all the way through like 6 is nighttime. It's like around this time that the sun's coming out. This is the sunrise. While this over here, no, this would be considered, fuck, this shit's kind of hard to wrap my mind around, unless I'm looking like, unless I had like a diagram, like something digital for me to look at. But however, So let's assume yeah, because technically that is spinning. It's spinning as the world is spinning. No, but it stays. The 12 p.m. is always aligned perpendicular with the sun. And let me look up that word. Perpendicular. I think I'm pronouncing it correctly. Perpendicular. At an angle of 90 degrees to a given line, plane, or surface. Which I think I'm misinterpreting. The two lines must cross at right angles to each other. Oh, I think it's okay. It's parallel in the same plane. Never intersect. Always the same distance apart. Have the same slope. Symbol is that railroad tracks are an example. But I'm talking about just one. Perpendicular lines versus parallel lines. Well, we can say that, like right here, C and D are like the sun, and B is the center of the sun, and A is planet Earth at its brightest point, or probably the moon on its brightest, at the same time, the brightest on the moon, because it's not going to change. If it's 12 o'clock on planet Earth, it's also 12 o'clock on planet on the moon. In perspective of planet Earth. Okay, so when we are in planet Earth and it's 12 p.m. and we're looking at the moon, and we can see this type of moon during the day, kind of like this. Obviously it won't really look like this, but this is more like a night view of the moon, obviously. But either way, we know we're like around here somewhere. Okay, right there. If you're looking at the moon and it's 12 p.m., then you're over here. 12 a.m. 12 a.m. you're at the opposite side of the moon. You're over here, because we know that the sun is obviously, if you're over here on the opposite and the dark side, you know that the sun is coming towards this direction, right? Because the world's always spinning, and it's on at a set time. There's 24 hours for one full rotation, one complete rotation. So now you know, you have a perspective of how long it will take for the light to eventually reach you. Okay? So without having a watch, you guys can technically look at the time just by looking at the shadows and where the light is at on the moon. And it's surprising, it's really interesting if you guys ever take the time to go outside, and if you guys notice the moon outside and you notice that it's about to be a sunrise, you guys will notice that you guys will be like right here. Okay? And then eventually you will start seeing the sunrise, and on the moon is also doing the same thing. So in perspective, you're right there. Okay? You're going to be right there. I hope you guys understand what I'm referring to. Because you guys just can't be at any other location other than what I am describing. But it's also true that you guys can be within this area, and especially on the opposite side of the moon, where aligned with this sunrise. Okay? So and like, this is happening to every other planet and moon, any object that's out there. Okay? Like this, for instance, the moon's right here. The sun. Okay? So remember, we have the this perpendicular type of illustration. So points A and B will always be aligned on the Earth and the Moon. And the Sun. The Earth and the Sun. And that line will always be at 12 p.m. Okay? But obviously the world's spinning, right? The world's spinning, but this remains true at all times. It stays constant. It stays the same forever. Okay? So, and this thing, the world could be spinning around. The world could be spinning around. I don't know if it spins right or left, but either way it's spinning. And as it's spinning, this thing here basically remains the same. Okay? The world is the one spinning, not the other way around. Okay, so let me see if I can show you guys like an example. All right, okay, I'm going to try my best to illustrate this further. So hopefully I could just do this once and for all, and never again. Okay, so we have that, and then we also need a picture PNG of planet Earth. Okay, so we're going to pull that up. We're going to get an image. We're going to drag that, and then we're going to open up uDoodle, which is an image editor, and I'm going to upload the first image that I dragged into my Finder window, where my images are stored. And then after that, I'm going to upload the planet Earth image, and once that's in position, I will be able to rotate planet Earth within this diagram for you people to understand exactly what I'm talking about. Okay, so let me pull that up. Just give me some time here. Okay. And obviously we have the North Pole and the South Pole. I think it's going to be so obvious. Where the North Pole and South Pole will technically be at once I start rotating this planet of the Earth around the clock. And this is taking a very long time to upload, so I hope that I will be able to share this content with everyone. Professionally as much as I can, okay? Because this is very stressful on me. Honestly, it is. This thing. Okay, now it's working. I don't know what just happened. Okay, so let me just erase this information. Okay, and then I'm going to upload the first image again. That I downloaded, that I described to all of you, and you guys clearly seen. The image I dragged from the internet into my folders, my Pathfinder. I don't know what this thing is referred to. The folders, files on Google, but on Apple it's called Pathfinder. So I'm just navigating through this, and I'm going to eventually get that image. Okay, then I'm going to drop in the Earth image, and you know what, I don't think I'm going to be able to change the opacity of this image, and if I'm not able to, you guys won't really be able to see exactly what I mean. Probably, but I will do my best to give you guys the best possible illustration that I am able to muster with the limited tools and resources that I have. I was going to say, you know what I mean. Let me see here. Yeah, see, I don't have options here to change the opacity. However, you guys already seen this, right? It's just the clock hands, so we don't need that. So I'm just going to expand this Earth picture here. That's good. And then I'm going to revolve it. Ooh, I was not trying to move it. Hopefully that's centered, but I want to revolve it. Okay. So obviously, I think it goes this way, clockwise. So the world is spinning, and you guys can see from the calendar, from the clock, what side is dark and what side is day, right? Because I already specified that this section that's dark is nighttime. This other half down here is daytime. So we can do this all over again. This section over here is nighttime. This other half of the circle is daytime. Okay? This laptop reminds me of fucking Windows. It's so goddamn fucking slow. So here is the image again, right in the center. And remember, the sun's over here. Okay, and I can't remember, the sun's always going to be at the 12 p.m., which is right here. It's always pointed that way, right? I already specified that. The light is over here. The night is on the other half of the circle. So there's a 180 degree straight line that goes that it basically stops at 180 degrees, and that's all technically like light time. Okay, obviously there is the North Pole and South Pole, right? Ooh, this thing moved again. Stay. So, as this thing is spinning, God damn it. Okay, I got it back on the center somewhat, and now I want to spin it, yeah, like that. So this is the rotation the world is doing. It's just spinning. Right? And it takes 24 hours for a full rotation. So this is technically like a calendar as well, because after 24 hours is considered a day. After 7 days is considered a week. After 30 or 31 days is considered a month. After 12 months, it's considered right on the 12th mark period is considered a year, or like right after the 12th month period is considered a year, right? So that's all the world's doing, is just spinning. But so like right in the center there's the North Pole or the South Pole. On the opposite side is the North Pole or the South Pole. Okay, because I don't know in perspective or whatever where that's at. And obviously if this was the North Pole or South Pole, it would be Alaska, right there, either frozen or like super hot, I guess. No, wait. Yeah, it wouldn't be super hot. It would be cold on either end, because the sun is hitting I mean, it's always hitting the earth like this, and it's spinning, and then there's the north and south. So obviously there's no snow where it's spinning, and it's spinning like a disc, right? So like, you guys already know, if it's 12 p.m., it's going to be the brightest right here. And then we have 1 p.m., not 1 a.m. We have 1, which is also considered 1300 hours, 1400 hours, 1500 hours, 1600 hours, 1700 hours, 1800 hours, and so on and so forth, right? But for a lot of you people, you guys understand it like 12 p.m., then 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., right? But since we're dealing with military hours, and we are wrapping this thing up around the planet, in perspective to the sun, and we're not looking at it from 12 hours from daylight, because I specified that there is a 180 degrees, which makes up half a circle, right? So from 6 a.m. to 12 p.m. is a 90 degree. There's 90 degrees, right here. 6 a.m. the center point, there's 6 a.m. and then 12 p.m. That's 90 degrees right there. So there's 4 parts in this. Over here will be basically, well, on the clock it'll be 9, but military hours is 1800 hours. So from the 12 p.m. to 18 p.m. it's another 90 degrees, 90 degrees angle, right? And then if we put the 6 a.m. through 12 p.m. and 12 p.m. through 12 p.m. 12 p.m. through 18 p.m. it equals, if you add 90 and 90, it equals to 180 degrees, right? So that's 180 degrees. That's half a circle. After that, it's the opposite. The opposite, because it's nighttime. Okay? Oh, and also, if it's spinning this way, that means that over here, these people that are right here are experiencing the sunsets. Over here, these people are going from the darkness into the light, so they are experiencing the sun rise, the sun rising towards them, right? Because if you look at it over here, you're looking at 12 a.m. and then 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m. Have you guys ever woken up at 5 a.m. in the morning? Right? So we have 5 a.m. and then 6 a.m. and then eventually you guys start seeing the sun rising. the world is spinning, and then the sun like we see the sun, right? And then eventually it goes down, and in perspective only, is basically going down, and we don't see it anymore. So by that time, we're over here, and we are experiencing the sunsets, and this happens over and over and over. It's just a pattern. It's been going on for a long, long time. And that's how they were able to make this clock. And that's why we know that it works, that it never changes. It's always constant. It never changes. It remains the same. Okay? But there is seasons. I don't know if the world kind of like moves at a different pace or different angle, but we do have 4 seasons. So something's happening. Something happens during these 4 seasons. Maybe the rotation shifts a little bit, but it always goes back. It always, maybe it's churning, but it's kind of like, doing something else scientifically that I can't describe. But either way, like I said, the world is spinning, right? And I can let me actually cancel this real quick, and I want to add an emoji of the sun. Well, since I can't pull it up there, let me type it up over here. Emoji of the sun. Okay, this one right here. Well, that's super small. Come on. I just want to make it a little bit bigger so you guys can see it. There it is. So you guys already know that the sun's always over here. The sun's always going to be right there in this diagram. Okay? In this illustration here. And then we have the earth that is spinning around and eventually I believe it spins completely around the sun after so many years. And it might take a long time, because I think like a few million or billion Earths can fit inside the sun. So it takes a long time for eventually the world to spin around the sun, because although it's spinning, it's spinning like the world is spinning like this around the sun, and it's spinning, and like spinning like that. But it's going around the sun, okay? But this would be considered like the hours. Eesh, it moved again. Again, with people, I'm not trying to move it like this. I'm trying to revolve it. Yeah, like this. Okay, so we know where the sun's at, the brightest. The sun's always going to stay there, regardless if you guys are experiencing sunrise or sunset. Okay, there's always going to be the 12 o'clock mark somewhere on planet Earth. Like right now, it's 2:25 a.m. Somewhere in the world, the sun's barely going up. Somewhere in the world, the sun's going down. Someone right now is experiencing the sunrise, and someone in the world right now is experiencing the sunset. Okay, so it never changes. This is always happening, and from this perspective, technically there is no day and there is no night. We just live forever. But like the Bible said, these are just to provide us with timing and seasons, technically, so we can better communicate with each other, so we could all be like on the same page. Okay, but other than that, this thing just keeps on spinning, whether we are alive or dead. See, so we could even go over here. We can start. Well, let's start over here where the sun's at. Okay, so it's 12. It's 12 p.m. Then 1. Then 2. Then 3. Then 4, then 5, then 6. But technically, it's not that. But it is like kind of 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m., 11 p.m., 12 a.m., 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., and eventually 12 p.m., which equals to a day. And we know how long an hour takes. One whole hour takes a long time. Like, I know this because I remember I used to be in school, and I would be looking at the clock, just waiting for me to come back home. Right? So, as I'm doing this like illustration thing, it might seem like a long time, but that's just for you guys to understand what I'm referring to. Okay, like I said, the sun's right here. This is always going to be 12 p.m. Over here is 12 a.m. Okay? So, and I think that I got this right. But like I said, it could be shifted, but I think that I'm accurate. So we take this into consideration. Okay, we can take this thing into consideration, and we can then go back to look at the moon. Okay, like stuff like this. Obviously, we already know what this is right here. This is looking at like kind of like a solar, whether it might be like a solar eclipse, where the moon is right in front of the sun, and planet Earth is right behind it. So the moon's right here, and the sun's over here, and we are over here. And since the light's coming this way, the moon is getting all of the sunlight over here, so we see nothing but darkness. That's what this is, right? Over here, the light is going this way, clockwise. Over here is 12 p.m. and then obviously it goes around this way. Now it could be in perspective to like I just described, where like in perspective to the sun around the moon, or it could be a flying object flying around another object. So if you guys get these calculations correctly, you guys will be able to communicate on a higher level. It can be used for the military, for military aerial, like aerial communication to destroy or to pinpoint a target at any given time, especially if the target has been identified and other team members have the knowledge of the targets. Because there could be many targets. Like, which target are you referring to? Right? So if they say, we need someone to attack these vulnerable spots at 2400 hours on this target, people will already know what they are referring to. And then obviously there's the compass, north, east, west, south, and then there's the North Pole and South Pole, right? And especially with technology, anyone's reference location or referenced location, can be used as a reference. And obviously, if someone is giving the command, they're using that as the 12 o'clock to the target. So if anyone's looking at their map, they know exactly what the pilot is talking about. And then they'll know how to to do that. Or it could be for like emergency landings, not regarding combat or defense or offensive type of combat whatsoever. It could just be for a landing on a or within a specific object, especially this type of thing can be used anywhere, but if we're looking at from a perspective of space, and we have an object that's obviously pretty much classified. Well, there's a lot of objects, but let's just take planet Earth as an example, right? That I really don't understand, because we're talking about a circle, a complete circle, but then we also have the North Pole and South Pole, so it's similar to the x-axis and y-axis, right? Like in mathematics, So how would this be used? It would be used because I already said we have the north and south, the compass, north, west, southwest. No, never eat soggy waffles, right? North, east, southwest, and then we have the y and the x axis. So that will be used. Obviously to describe what's above and what's below, and then it can be like, negative, because remember I specified already that it's 4 parts, and each part has 90 degrees, which makes up 360, which equals to a circle, right? It makes up a circle, which we have there. Half of that is 180 degrees, which is right here, right? So it could be like negative 9 plus 4, right? Or it could be negative 4 plus 1. So you guys will kind of have a reference based on that. But anyways, that's just like a side thing, and I don't really want to get into that right now. So like we can see the shadows right here. That's why I pull these images up. See, the sun's over here, and look at where the shadows are. The shadows are exactly the same location, but some are bigger than others. Some objects are bigger than others. And some are, they're scattered around the sun, but nevertheless they are circles, right? So pretty much this formula will work for every planet out there, right? And technically that's how they invented the clock. Someone a long time ago in history figured this stuff out. I don't know why this thing is not going away. It's like they're advertising while I'm recording. So don't bother with that, people, because that's not important. So yeah, like when you guys out there, this stuff, right? This is obviously fake. Like, there's no shadows. There's no, like, I was going to say contrast, but I don't know. It's weird. That's why a lot of this stuff always tripped me out when I was growing up as well. because first of all, it doesn't even make sense that we're stuck in a bubble, freaking circle, a ball. That's just so weird. It makes me wonder what the heck we are. Like, we're just like small bacteria compared to bigger cells. You know, it's just like minutely. We have red cells, white cells. You know, we can eat and the food gets distributed and stuff like that within our bodies on a more minute level. I think this is on a bigger level, and we're just little bugs, like bacteria on your finger, or like bacteria, like, let's say, in the eye. You know, because the eyes are round. I can't make this stuff up. I don't understand, honestly, what the heck we are, what we're doing here. But that's besides the point, right? That's for a whole different teaching or whatever. Right now is like, okay, we are here. Doesn't matter how we got here or what the heck our purpose is. I'm just trying to show you guys, you know, things that I trip out on, things that I don't really understand. See, it says you are here. We're one little small dot compared to the whole solar system. And look at all this. I don't even know what this is. But see, like this, we have right here, we have like the sun over here pointed. This is where the cursor is at, is where 12 o'clock is. Yeah, I hope I didn't click on that. So 12 o'clock is like right here somewhere. 12 p.m. And like I said, over here is 12 a.m. Right? Because there's 4 parts. So there's 12. The opposite of that is, which is equal to 2,400 hours, to be precise and accurate. But it's also equivalent to 12 a.m. Okay. Okay, so that's all there is to it. So like, anyways, like, hopefully you guys understand now. When I'm looking at when I'm on Earth, because I'm always on Earth, you know, and I'm always joking around saying, oh, I'm, in planet Mars and stuff like that. But anyways, so like, let's say you guys were looking at this and you guys were looking up at the sky. and you guys were able to see this. And it's if it's 12 p.m. that means you guys would be right here. If it's 6 p.m. you guys will most likely be like over here. If you guys are, if it's oh yeah, I have it right here. Okay, so there's 12, and then there's 6, and then there's 1800 hours, which is equivalent to 9 p.m. So it's either over here or over here, and then so either 6 p.m. is over here or 6 p.m. is over here. I'm sorry, 6 a.m. or 6 a.m. and then there's 18 and then 1800. Alright, and then obviously over here is the 2400 hours, depending on what direction this thing is spinning. Like, it could be spinning this way or this way, and I don't really understand what direction it's spinning. But let's say it's spinning this way, that would mean that over here will be the sunrise, because the sun is moving towards this direction. Over here, the people of the world are experiencing the sunset, because it's only getting darker and darker, right? So so that would mean that if you guys are over here, it'll be sunset. So it will be 1800 hours. This is relatively somewhere where you guys will be at, around this area, whether on this side or on the other side. And if you guys need help to understand that, I'll be more than happy to share it with you guys, because all it is like a ball. You grab any ball, basketball, soccer ball, tennis ball, golf ball. I mean, let me see, do I have a ball in here? Something round. The only thing I have in here that's like round is rocks, and they're covered in soil. So I don't really want to mess with those rocks at the moment. Man, my shirt touches my skin and it feels like a spider or something's crawling on me. It's so annoying. It's so weird. Like, right now my t-shirt was touching my arm right here, my hand, and I felt like friction. Something was crawling on me. I trip out on stuff like that. Anyways, let me see. Something round. Jesus Christ, I can't find anything that's round. Oh God. Well, we can use this plant as an example. This here will be considered the daylight. This over here will be considered the nighttime. Dark color for the night. This will be considered the day. This will be considered 12 p.m., which is constant. You know, 12 o'clock is right here. 12 p.m. is right there. This is you. Now you're in the dark. Now you are hanging out at the beach and it's 12 p.m. And over here you're experiencing what? Sun sets. Right here is 12 a.m. 6 a.m. 12 p.m. 9 p.m. 12 a.m. 6 a.m. 12 p.m. You guys get it? It's that simple. So you guys can actually use something like this, anything that's round or whatever, like even this, for you guys to understand what it is I'm describing to all of you. So anyways, so I was on planet Earth. I'm always on planet Earth, okay? But anyways, I'm getting confused. I'm here on Earth and I am noticing that it's the sunset. So I looked up at the moon and I figured, hey, if it's sunset over here, it's sunset like over here on the moon as well. So I was like, that's probably where I'm at right there. Wherever that's at, that's where I'm at as well. Pretty much. Right? Because the moon and planet Earth are, it's all, the sun's always constantly moving, but it's like, and I don't know, I think they might be spinning at different time rates, you know, but anyways, I just tripped out on this, and maybe there's a time when eventually, when this repeats itself as well, eventually there will be a day when the moon will be in the same position and it will be experiencing the same sunsets at the same location. And it's not rocket science, people. It's simple common sense. It's just a pattern. You know, I mean, obviously these are massive objects, but we don't have to look at them as you know, massive objects. We can look at them as small easy to understand, illustrative type of objects, just like when we look at them, in image form. Obviously, for us to see this in real life, for us to be this far, we would have to be, I don't know how many miles away from the sun, but Neptune is, let's look up how far Neptune is from the sun, and whatever that number is, we have to multiply that by 10 at least to be from that perspective that we have, looking at all of these planets. So Neptune distance from the sun, obviously in miles, it says 2.7794 billion miles. So we can round up to 3. 3 times 10 is 30. So 30 billion miles away approximately to get this type of view. Because remember, from the sun to Neptune is 2.7. If we were at that distance, we would only be looking at from here this way. So this picture is way zoomed out, like at least 30 billion miles away, roughly, approximately, more or less, and definitely not a lot less than that. In case you guys are like, oh, it's only going to be like, 10 billion miles away. Maybe, but I doubt it. Because we're able to see a whole lot more, right? So these little graphs or whatever, they can be very deceptive in terms of perspective, right? And there is no, like, maps, planet Earth maps have a reference. Oh, Google Maps has it. Let me see. They have a graph. Watch. Google Maps. They have the graph, and I think it specifies it by miles. So the same should be true when we are looking at a graph of the universe. No, I don't have any internet. Now I do. Okay, there it is. Come on, give it to me. What's wrong with this thing? Is this like... It's right here. 10 miles. Oh my god. I just seen a cat. That was scary. Hey, kitty. I got scared at first. But look at it, people. You see this thing right here? It says 10 miles. So if you guys measure from here to here, that's only 10 miles. So you guys can grab that. The same distance. And put it anywhere on the map. And that's exactly 10 miles. And if you guys count 2 of them, you guys just add 20 miles. If you multiply it by 3, that's 30 miles. So if you guys are looking at how to get from from one location to like another, see right now it says 20 miles. So this will be from here, this is like 1 and then 2, so like approximately 40 miles from here to here. And then if you guys zoom out more, it's see, guys, it got smaller. See how it got smaller? See, now it says 100 miles. Now, from here to here, instead of it only being 10 miles, now it's 200 miles. So you guys can, basically figure from like one point, wherever you start the point, wherever you end the point, it'll be 200 miles. And then you can multiply it from there more. So like from California to like Nevada over here is like 200 miles. Well, from here, from the United States of America, Los Angeles to like Vegas is just about 200 miles, maybe a little bit more, or maybe a little bit less, but you guys get it. And look at, I live right here in Riverside, so like I could even like GPS it for you guys to understand what I'm talking about. So let's get directions. Obviously, the car, it says 3 hours and 36 minutes. It says 244 miles. You see that? $244 miles. So remember I said more or less? And then over here it says via California 247 north and I-15 north 311 miles. So it depends what route you take. Obviously because of the roads. Right? So anyways, when we are looking at stuff like this, I think it should show the same type of data. Because we're mapping out the world, the universe. I shared this before, back in the day. people used to believe that the world was flat. You know, the way I look at it, ladies and gentlemen, and I want to make this quick as possible, not to confuse anyone, but I think people were sending others from one country to other countries in boats and ships, and it was similar to what Elon Musk wants to do, SpaceX, with the colonization of planet Mars, because there is a lot of trial and error. People would just disappear. Okay? Let's just put it out there for what it is. There's no falsification information regarding this stuff, because they were just learning. They're sending people from basically one island to another, and some people would make it while others didn't make it. And it was similar to like spaceships, like rockets. Some will make it, some won't. That's just how it is. But in today's time and age, we have AI technology, which benefits us, the human race, right? And the benefit of future exploration for humanity, that's who it ultimately benefits. Now, they might put me in a ship, and something might go wrong with the ship, and it might not land. Me and the whole crew in the ship might die. But before we get in that ship, before we sign the waivers and all that, they let us know the dangers, the possible outcomes. They know that for the most part, once we go over there, we're staying over there. And because back in the day, traveling in a boat was like the fastest form of transportation. But now that's not the case. Now we have jets, we have rockets. I believe 100, 200 years from now, we will be able to go from planet Mars to Earth, or from Earth to planet Mars, in a matter of minutes. So, of course, it's going to be the way that I'm describing it, because we're just learning. But I think that we will get there eventually, and after that point, in the future of humanity, this futuristic date in the timeline of humanity, we will be looking into the colonization of other moons, possibly other planets, and stuff like that. But yeah, that's all I really wanted to like get out of my mind for this video. Well, anyways, I hope you guys like this video. Share it, or don't. I don't know if I'm accurate 100%, but you know, and obviously you know, when I'm spinning the map, the world around in this graph, when I was spinning it earlier, it's also changing the north and south, and you know, the compass, it's like changing, you know. So I don't know, it's just like I don't know. You guys understand, right? I know it's super hard for me to describe it, but you people understand what I'm talking about. Anyways, I'm going to bed. Good night, everyone, and God bless everyone. And I hope we figure all this stuff out with time travel and space travel, and I hope that we get to travel much faster sooner than later, so we can, you know, maybe take field trips out to, you know, out in space sooner than later. And it's not that bad of a ride. It's equivalent to, you know, boarding an airplane and looking out of the windows, you know, and we look out and we see all the cars and all the people and all the houses and all the trees, and everything looks so small. Like, people look so small, like if they were ants. They look like ants because they're so small, you know, in comparison to like the altitude that the airplane is, which you are at. And you know, I think that's how it's going to be when we're traveling in space. That's all it really comes down to. It's not like, you know, like something to be afraid of. You know, a lot of people would be afraid. Like, a lot of people are afraid to like skydive or bungee cord jump. They're afraid of a lot of things, and you know, don't get me wrong, I would be afraid too. Like, I have never bungee jumped before, and I never skydived. I never went scuba diving, like under the ocean. But if I did, I would be paranoid. I would be so afraid. I would be thinking that a shark would just come up to me and eat me alive. That would be like my biggest fear. Even if I was surrounded by professionals. And like in the movies, or like in the National Geographic channels, when people are scuba diving around sharks, hammerheads, whales, and other sea creatures, to me, that is super creepy, and it's just not my element, you know. That's not the place I want to be, you know. And I think that will panic me more than going to space, with the probability of the oxygen getting depleted, or running out of fuel, or having a malfunction on the ship, or our water getting contaminated or something like that. I would be more afraid going in deep sea scuba diving, as opposed to going deep into space inside of a vessel, kind of like I can probably go deep sea. I could probably go deep in the sea if I was like in a submarine. That's not that bad. But if fucking if freaking no protection, going into the sea, like deep sea scuba diving with all the fish and all that, that would be one of my biggest fears above everything else, personally. But some people do it, and I guess I would feel more confident doing that if I was out there with professionals. Then yeah, I would do it. But I would probably shit myself. No lie. I would be so afraid. But someone has to do it. Someone has to do the job, So, to me, it ain't a big thing. And just like anything else, like even skydiving, everyone has to go through training. There's certain things people have to do to prepare themselves to eventually jump out of an airplane. Like, you guys just can't do that just for fun, unless you own your own airplane and you happen to have your own parachutes and no one's around. You might get away with it. You might not get penalized. You might not even get incarcerated, right? You might not have to be dragged into court for doing something so stupid. But that's how they did in the beginning of time, right? Someone just got the bright idea, like, hey, I invented a parachute, let's go skydiving. But there's safety and everything. There's rules and regulations. It's just like when someone buys a weapon, they buy a gun and they want to take it to like the desert to start shooting it. Like, no, you don't want to do that. Like, if you get caught, there's so many people. Those fines will be super expensive. And not just that, but if a police officer sees you shooting a weapon in the middle of the desert and they have to approach you, most likely they're going to approach you by giving you orders to put your hands up in the air and to drop your weapon. That's the way I would handle it. That's the way I would go around. That's the way I would go about it. Not that I would be afraid that you would shoot at me, but just for precautionary measures, because for whatever reason someone's shooting the weapon out there and then they decide to point that weapon at me, at least I'll have an excuse to shoot, and a lawful one, legal boundaries to open fire, but if I go in blindly, and I get caught with the element of surprise, the weapon's pointed at me, what do I do? I'm going to instantly start thinking, oh my god, I should have commanded these people to raise their hands and to drop their weapon or whatever, right? So instead of going through all that, I would just plain out tell them, like, fuck all that shit. But not that I want to, not that I would want to shoot at innocent civilians or even military personnel who just want to go have fun and shoot a weapon around, but it's stuff like that. Like, there's rules and safety for everything, for a reason. But I think that I could do it. I've been in vehicles, I've been in airplanes, I've been inside movie theaters where it's super, super loud and there's a lot of turbulence and explosions, sound effects and stuff like that. It doesn't alarm me, it doesn't bother me, but and it doesn't bother a lot of people. Like, a lot of people, they can go to a movie theater and they could feel vibrations, they could feel everything rattling. But imagine that in an airplane. Imagine that in a submarine. Imagine that in a spaceship. That's when everything will get intensified. I would be afraid times 10, if not greater. I would basically be shitting bricks, but if everyone around me is calm and collective, so will I. So it's not that bad, and it is what it is. We can only do so much. But I still don't get why you people want to go colonize planet Mars when we have the moon right here. Our neighbor object. Just doesn't make sense to me. But I'm sure you people have your reasons. I just hope that you guys really think everything through. Because even like boats back in the day, boats are small. They weren't able to resist high wind advisory weather conditions. A lot of boats sunk to the bottom of the ocean. A lot of people disappeared. There's a lot of things to consider. There's life vests, a bunch of other things, so I hope you people really consider everything before you guys start sending people out there. Hopefully they get sent out there to build and to construct and to thrive, and not to go over there to die. Well, anyways, God bless you all, and see you guys all in the next video.